Welcome back, guys, to week 5 of our Arduino journey. So, the last few videos have been on the longer end, like 18 minutes or so. So, this one is going to be slightly shorter, at least I hope so, since we only have one thing to go over. So, this tiny new little component on the board we have today, this is something that's called a push button. So in today's section, we have to go over push buttons and switches. So a switch is basically two or more conductors that can be mechanically connected or disconnected, and a push button is something similar. It's basically a momentary switch, but it only connects when pressed. So we have a push button over here. So what that means is, like, you can see there's four conducting pieces over here, two here and one, two here. So what that means is, there's two of these that are always connected to each other, like this, these. Okay, the camera is not focusing. Okay, so there's four here, one, two, three, and four. So these two, the one on opposite ends are always connected, and these two can be connected by pushing this button. So let's go over some notes over here. Yeah, so as you can see, this is the diagram of the push button. So as you can see, parallel ends are always connected, like I said, and upon pushing the button, the ends on the same side, which same side meaning the one on the shorter, the one between, like the ones that have a shorter distance between them, they get connected as well, and then current starts flowing between them. Okay, we'll go over that later. So today we'll just explore how this works, and we'll build first a circuit with an LED, and then we'll try building one with an active buzzer as well. If you don't know what that is, I have a video up on the channel going through that. Okay, so let's start with the LED. So first thing is, we're going to connect our push button onto the breadboard. So what we need to do is connect the parallel ends. So these two opposite ends that are always connected, we need to connect them across, not in the same line, because then that will short the circuit, as you guys know, and current will like not flow properly. So we connect it across like this. Let me just make sure it's connected properly. Okay, I might have messed this one up. Let me just get another one. Oh, and I forgot to go over this. This is basically something that just came with my kit. It's not really a component. You can just put it on top of the push button to just make it seem more like an actual button. Okay, so besides that, we connect this across like this. Okay, so first I'll show you what happens when you connect the LED across parallel ends, like across the ends that are always connected. Okay, so what we'll do is one wire into here. Okay, and this goes into the 5 volt. Let me just see if that's right. I hope you guys can see. Okay, my bad. That goes into the 5 volt, and then we have a resistor that goes into the parallel end. Then we connect our LED positive to negative, one wire this way. Give me a second, I'll just make the circuit and then go over it. This goes into G and D. Okay, so just to show you guys what I've done here, I've connected the circuit like opposite the parallel through the parallel ends of the switch. So parallel ends are connected, not the ones that are disconnected by the switch, but the ones that are already connected, like I explained to you. So what do you think will happen now if I plug this into my laptop? Let me just try. Great. So as you can see, the LED just turns on, and it's inconsequential whether I press the push button or not. Now, like I said, that is only because these ends are always connected. Like if you can see the diagram, the parallel ends are always connected. They're never disconnected. But the push button, what it does is once you press it, it momentarily connects the ends closer to each other, which makes current flow through. So what we need to do is actually to make this work like an actual push button, let's connect the resistor and the LED across the perpendicular end. Okay, let's just try that. Um, my resistors have been bent out of shape too much, so I'm not really able to see clearly whether I'm even doing this right or not, but we'll find out soon. Okay, let's see, hopefully. Yeah, see, so now it is working as intended. The push button does work. Let me just show you guys how I did that. So as you can see, it's connected through the ends that are on the same side. So once the button is not pressed, there is no current flowing through because the conductors aren't connected. But once I press the button, the conductors get connected and the current starts flowing through, goes to the LED, and so on. Now let's try the same thing but with an active buzzer. Okay, so we'll just have to write a few lines of code. I'll just see you guys on the IDE and we'll be back very shortly. Yes. So just to remind you guys, okay, so let's just set up a variable first for our output pin. So since we're using an active buzzer, we don't really need to do this, because the active buzz actually we do, but I'll just get into more of that 1 second. So what I'm saying is I'll select a pin that has pulse width modulation on. So like I've already explained to you guys, pulse width modulation is basically just like analog pins. You can see more of that on one of my old videos. So it's just basically pins, digital pins that have like weird squiggly signs beside the number. So we're going to use one of those pins. We don't actually need to do that for this since it's a active buzzer, but in case you would like to do this and play some, more complicated tunes with the passive buzzer, you can do that. So I can see on my board that pin number 9 is having pulse width modulation. So we'll just keep the buzzer. Okay, let's do buzzer pin. And then just the usual stuff, pin mode, buzzer pin. Okay, let's do snake case. My bad. Output. Okay. And then digital, right, buzzer pin. Let's do high. Okay. Just for the sake of convenience, we'll just buzz maximum. Okay, so this should be all we need. I'm pretty sure. Let's just verify it. Yeah. Okay, so yeah, like I said, you can use this with the passive buzzer as well if you guys would like to just, but for the sake of simplicity and since I'm only doing this to explain, I'll just use the active buzzer. So I'll get back to you guys with the circuit, and then we'll install the buzzer and get right into it. Yes, so we're right back where we left off. So I've actually disconnected the LED on my own, and I just connect this. So like I told you guys, it's simple. The positive negative is like convention. Any other longer is positive, shorter, but they've actually given the positive symbol just as a guide. So let me just connect that as usual. Use a resistor. Hopefully this works. I to explain to you guys, I can't really see properly. The lighting is very weird. Okay. Okay, let me just upload the code to my Arduino. Yep, it is working. I don't know if you guys can hear that or not, but yeah, it is working. Okay, so that was it, I guess, for our section on push buttons and switches. So I hope you guys have a decent idea of how push buttons work, since we're going to be using them a lot. So do join in for the next one. The next one is going to be very interesting and quite long. So we have our section on an RGB LED. So it's not like the usual LEDs that we're used to using. It's an RGB LED. It's very interesting. So we'll go over that in the next video. So see you guys next time.